All right. Now, we are going to actually do 5.4 now, and you might remember what you see here on the screen from 5.3. But I'm going to be using this here to basically get across the one very, I hope, simple point that we find in 5.4. In 5.4, what we're looking at is how do we use an ordinary truth table in order to determine if an argument is valid or invalid. And the good news is here that using an ordinary truth table, we can determine if an argument is valid or invalid very quickly. So to do that, what I will say here is I will simply begin by adding an extra slash to this line here. And what I have done, or at least symbolically speaking, what I have done is I have now turned this into an argument. It used to be 3 statements, right? And we were testing if they, for example, were all consistent. But now we're going to turn this into an argument. We have 2 premises and a conclusion. And in order now to determine if this argument is valid or invalid, the process is actually very simple. Okay? And all we need to do is remember what we talked about back in chapter 1, right? In other words, think about what valid actually means or what that term means. An argument is valid, right? Of course, it has to be deductive. Remember that. But an argument is valid if there is no possibility for that argument to have all true premises and a false conclusion. Right? That's what validity means. It's simply designating an argument that could never have all true premises and a false conclusion. And so with that in mind, if we can show, as we did, for example, in 1.5 with the counterexample method, if we can show that it is possible to get all true premises and a false conclusion for any given argument, we have shown that that argument is invalid, right? Because a valid argument would never let that happen. So, having said all of that, how does that apply to an ordinary truth table like this? Well, here's what we can do. Look at this first claim here, which is now, right, I'll put my face in there. Now this is a premise, right? This is a premise. And so we see here in the first row of this truth table that if this premise has all A, B, and C being true statements, the first premise will be false, right? So in other words, this first row will not show us all true premises and a false conclusion. And in fact, to use an ordinary truth table to determine validity, all we need to do is create this truth table for your argument like this and hunt row by row for all true premises and a false conclusion. If we can find even one row where we get all true premises and a false conclusion, we will have shown immediately that that is an invalid argument. So this first row clearly will not show that we have all true premises and a false conclusion. The second row, again, this is going to go pretty quickly here, right? Because the second row cannot be a row where we have all true premises and a false conclusion. The third row is the same situation because we have a false premise there. Fourth, fifth, and sixth row. None of those rows will be rows where we get all true premises and a false conclusion. So it's only when we get down to the seventh row that things get a little bit more interesting, right? Yes, in the seventh row, we have a true premise, and then we can go ahead and look at the second premise. And what do you know? In the seventh row, the premise is true once again. And so what that means, and I know you can see this, but what that means is that if this conclusion in the seventh row here, in the conclusion, if that turns out to be false, we will have shown that this is an invalid argument. We'll know that right away. But of course, as you do see here, the conclusion is true in the seventh row. So that row is not an example of all true premises and a false conclusion. That row doesn't show that it's invalid either. And so we'll only have one more shot at this, excuse me, one more shot at this, and that is here, excuse me, in the eighth row. And in the eighth row, look at what we have. The first premise is true. The second premise is true. And what do you know? The conclusion is true. Is false, right? So we have all true premises and a false conclusion. And so, in fact, what we want to do here, what we want to indicate, is that this row shows that the argument is invalid. This row shows that the argument is invalid. In other words, and just to, again, try and make this a little bit more concrete, right? Go back in your mind to when we were discussing 1.5, right? The counterexample method. Well, excuse me. Remember in the counterexample method, we had some argument, some abstract argument, and then we made substitutions. We had an argument form. We made substitutions into that argument form in order to get all true premises and a false conclusion. Well, what this ordinary truth table tells us is that for this argument here, when A, B, and C, are false claims, we will end up with a true premise, and a false conclusion. And as we saw in the counterexample method in 1.5, that always indicates that this is invalid. Okay? And so really, just to summarize here, what we're doing when we construct an ordinary truth table for an argument is we're simply going to construct it and then look row by row for all true premises and a false conclusion. If we find a row like that, that row shows this argument is invalid. This row is not invalid, right? Rows are not valid or invalid. Arguments are valid or invalid. But this row would show that it's invalid. Now, if this conclusion right here had turned out true in this spot, which it doesn't, but if it had turned out to be true there, then of course we would never be able to find a row where we have all true premises and a false conclusion. And if there is no chance to have all true premises and a false conclusion, that is what we mean by a valid argument. So in other words, if that had turned out to be true right there, we wouldn't write anything about invalid. We'd say this is a valid argument. Okay?